A continued fraction is an expression like this, where you have an integer plus a fraction, but the fraction itself is an integer plus a fraction, and the denominator of that fraction is also a fraction. So an expression like this is called a continued fraction. And if the numerators of all the fractions, like in this case, are ones, it's called a simple continued fraction. And if the continued fraction ends, like at this point, the final denominator is just an integer, then it's finite. So this is a finite, simple, continued fraction. Finite because the last denominator has no fraction in it, and simple because all the numerators are ones. Now it's hard to write or to type out a continued fraction, but if it happens to be a simple continued fraction, then all that's important are these numbers, and that describes all the information about the continued fraction. So we can describe this big expression with this shorthand, where we write the number here, the whole number, and then we put a semicolon, and then we write all the different denominators, so 3, 4, and 5. Okay, so this is a shorthand for describing this simple continued fraction. Again, simple because all the numerators are 1. So for practice, would you express this simple finite continued fraction in the shorthand form? And the answer is 5, semicolon 3, comma 6, comma 4. One skill that I want you to learn from this video is how to convert a simple or any continued fraction that's finite into a single fraction that's, in this case, going to be an improper fraction. And you do this by working from the inside to the out. So you start with the sort of final denominator. This basically, we do it in this order. If I were to put parentheses around everything, I'd go like that. So you start by doing 4 plus 1/5, which is 21 over 5. And I'm going to go like this, just change it to 21 over 5. But now, especially if there's a 1 in the numerator, which there are for the simple continued fractions, that allows me to turn 1 over 21 over 5 into the reciprocal, 5 over 21. So now my fraction looks like this: 1 plus 3 plus 5 over 21. Now I'm going to add these two numbers together, and because of the 1, I'm going to take the reciprocal of that. I'll do it on the side. 3 plus 5 over 21 is 68 over 21, but it's 1 over that, so it's 21 over 68. And then finally I can add those two things together. If I want to have improper fraction, I mean, I could just write 2, just get rid of this plus sign. But if I want to go further, 136, I would end up with 157. Over 168. And that's the skill of converting a continued fraction that's finite, especially one that's simple with the ones on top, into an improper fraction. Let's try that for this question now. Can you turn this finite simple continued fraction into an improper fraction? Go ahead and do that now. And the answer becomes 420 over 79. The next skill is, can you go in the other direction? If you're given a fraction, in this case improper fraction, can I come up with a finite continued fraction representation? And the answer is yes. There's actually more than one way to do it, but if it's a simple with the numerators all being ones, there's only going to be one way to do it. And here's the way you do that. First of all, you can divide 68 into 157 to get 2, remainder 21. So at this point I have 2 plus 21 over 68. And here's the clever trick. We rewrite 21 over 68 as 1 over 68 over 21. You see, that gets me the one that I want for my simple continued fraction. And now this 21 over 68 was a proper fraction with the numerator being smaller than the denominator, but when I turn it to 1 over 68 over 21, now I have 68 over 21, which is an improper fraction. So on the side, I can do 21 into 68 and get 3 remainder 5. So I get 3 plus 5 over 21. Now I take the 5 over 21 and rewrite that as 1 over 21 over 5. And then finally, 5 into 21 is 4, remainder 1. Plus 1/5. And I'm allowed to stop now. Why is it that I'm allowed to stop? Yes, it's because finally and eventually, hopefully, you end up with a remainder of 1. And when that happens, you get to stop the process. We can write this continued fraction as 2 semicolon 3 comma 4 comma 5. As a challenge, would you now turn 978 over 235 into a simple finite continued fraction and write the answer in what's called linear form, the shorthand form? Okay, and the answer should have ended up as 4, 6, 5, 2, 3. In other words, 4 plus 1 over 6 plus 1 over 5 plus 1 over 2 plus 1 over 3. Our last denominator is just an integer. Sometimes you see these brackets around here. Okay, that's your introduction to continued fractions.